In this video, we're going to look at the tangent and chord properties of circles and solve some example problems involving those. Firstly, the tangent. As we know, a tangent line touches the circle at one point and is 90 degrees to the radius. And what you need to know about a chord is that a chord meets the circle at 2 points, and the perpendicular bisector of the chord goes through the center of the circle. This is from your GCSE circle theorems. If you were to draw a diagram, it might look something like this. So you can see we've got the circle, we have a chord here, and we have its perpendicular bisector, and that always goes through the center of the circle. Check out my video on circle theorems to see a proof of that. Now notice there are three elements of this theorem. There is the fact that the lines are perpendicular. There's the fact that the chord is bisected, and that the line goes through the center. Now you only need two of those elements to conclude that the third is true. So if you have two of the elements, you can fill in the third. For example, if you know the lines are perpendicular and the chord is bisected, then you know that the line goes through the center. Or you might be told that the line goes through the center and the chord is bisected, then you can conclude that the lines are perpendicular. In some problems, you might only know two of these things, but then you can conclude that the third is true as well. All right, let's have a look at an example where we need to use this theorem. So in this example, the question says the points P and Q lie in a circle with center C, as shown in the diagram. M is the midpoint of the line segment PQ. The line L passes through the points M and C. And this is going to be a three-part question. The first part says, find an equation for L. So what do you need to find an equation for a straight line? You need the gradient and you need a point on that straight line. So far we don't have either of those things, but we can find them both because we can say that these two lines must be perpendicular. Why can I say these two lines are perpendicular? Because L passes through M, and they tell us M is the midpoint of this chord PQ, and also that L passes through the center. So that's enough to say that those two lines must be perpendicular using that theorem that we just talked about. So we can find the gradient of PQ, and then the gradient of L will be the negative reciprocal of that. So let's firstly find the gradient of PQ using y2 take y1 over x2 take x1, the rise over the run. So y2 will be -5, subtract -1, and then x2 is 3, and subtract -7, so we get -5 plus 1, which is -4, and 3 plus 7, which is 10, which we can simplify to -2 and 5. That means that we now know the gradient of L. Can you tell me what that would be? That's right, it would be 5 on 2. So the gradient of L is 5 on 2, and here we need to state our reasoning. So we say as M is the midpoint and L passes through C, which is the center, line L must be perpendicular to PQ. So we should always give reasons for our working out when answering these types of questions. We have the gradient. Now we need a point on that line. How can we get a point on that line? Well, because M is the midpoint of PQ, we can use the midpoint formula to find M. So using the midpoint formula, this is x1 plus x2 on 2, y1 plus y2 on 2. That gives us the two coordinates. So -7 plus 3 and -1 plus -5. This will be -4 on 2, which is -2, and -5 take 5 is -6 divided by 2 is -3. So we have M, and now we can use the point gradient equation to find the equation for L. So this is y take y1 equal to M times x take x1. Using that point and the gradient of 5 on 2, plug those in, we get y subtract -3 from this point equal to 5 on 2 for M, and then x subtract -2. Simplifying that, we'll have y plus 3 equal to 5 on 2 plus 5. So notice firstly this would be x plus 2, and then when we expand those brackets, we get 5 on 2x plus 5 on 2 multiplied by 2, which simplifies to 5. And then subtracting 3, we get y equal to 5 on 2x plus 2. So that's our equation for L. There were three main parts to that question and three formulas that are really important to understand and remember. Okay, part B says given that the y coordinate of C is -8, show that the x coordinate of C is -4. Now because C lies on the line L and we have the equation for L, this point should be a solution to this equation. So what we can do to verify that the x-coordinate is -4 is to substitute -8 into this equation and see what we get for x. So let's go ahead and do that. So substituting -8 for y, we get -8 equal to 5 on 2x plus 2. And now solve for x and see what you get. So subtract 2 from both sides, we get 5 on 2x equal to -10. Then multiply by 2 and divide by 5. That would be -20 divided by 5. That's -4. And this verifies that C is the point -4, 8, because this is a solution to this equation. So let's make a note of that on our diagram. The center is -4, -8, and part 3 of this question says find the equation of the circle. So we have the center. What's the other thing we need for the equation of a circle? It's the radius. So how can we find the radius? One way is to use the distance formula, so we could find the distance between the center and either one of these points, so Q or P. I'm going to use P. So we know the center using the distance formula, which is the square root of x2 take x1 squared plus y2 take y1 squared, where C I'm going to call x2 y2. This will be -4 subtract -7 all squared plus -8 subtract -1 all squared. -4 plus 7 is 3. So that's 3 squared, and -8 plus 1 is -7, which is the same as 7 squared. And then 49 plus 9 is 58. So we get the distance between C and P of the square root of 58, which is the radius. So now we can say that the equation of the circle will be x plus 4. Remember, it's always the opposite sign of the coordinates in the center. So x plus 4 squared plus y plus 8 all squared equals the radius squared, which is 58. So that's an example of a problem where you have to use the fact that if a chord goes through the center and it bisects the chord, then it's also perpendicular. Let's look at some examples involving tangents now. This question says the point 1, -2 lies on the circle with center 4, 6. Find the equation of the circle. So we have the center of the circle. What's the missing piece in the puzzle? It's the radius. We need to find the radius. And you could do what we just did. You could use the distance formula. So you could find the distance between the center and P, because they tell you that P lies on the circle. That means it's on the circumference. So the distance between the center and P would be the radius. So you could use the distance formula. You could also use this method that I'm about to show you. So write down what you know so far. So we know the center is 4, 6. So the equation of the circle would look like this. X take 4 all squared plus y take 6 all squared equals r squared. So leave the r in there because we don't know what that is yet. Once you write this down, you can plug this point into the equation, and that's going to give you a value for r squared. So plug 1, -2 in for x and y. So we get 1 take 4 all squared plus -2 take 8 all squared. Then we can say r squared will equal 3 squared plus 8 squared. That's 64 plus 9, which is 73. So r squared is 73. Then we can say the equation of the circle will be x take 4 all squared plus y take 6 all squared equals 73. Part B says find the equation of the tangent to the circle at P. What do we need for the equation of a straight line? We need the gradient and a point on that line. Well, we already have a point on that line because the tangent is going through P or touching the circle at P. That means P is a point on that line. So we only need the gradient. How can we find the gradient of the tangent? Well, if it's 90 degrees to the radius, then all we need to do is find the gradient of the radius. So we want to find the gradient of the radius from the center to P. That will allow us to find the gradient of the tangent. So to find the gradient of the radius, we can use these 2 points using our gradient formula, y2 take y1 over x2 take x1. This will be 6 subtract -2 over 4 subtract 1. So this is 6 plus 2, which is 8, and 4 take 1, which is 3. So the gradient of the radius, which is 90 degrees to the tangent, is 8 on 3. Can you tell me what the gradient of the tangent will be then? The negative reciprocal of 8 on 3 is -3 on 8. So the gradient of the tangent is -3 on 8. Then we can use the point gradient equation, plug in the gradient, plug in that point, 1, -2. So y subtract -2 equal to -3 on 8 multiplied by x subtract 1. Simplify this, we'll get y plus 2 on the left hand side and -3 on 8 x plus 3 on 8 on the right hand side. Remember that 2 negatives make a positive, and then simplifying this, we would have 3 on 8 subtract 2. Remember your addition and subtraction of fractions. Remember how to do that. We would have to turn that into 16 on 8. So we'd have 3 on 8 subtract 16 on 8, which is negative 13 on 8. So our final answer there is y equal to negative 3 on 8x take 13 on 8. And if the question said write it in a certain form, sometimes it might ask you to write it in this form, where you have everything on the left-hand side equal to 0. So in that case, you'd have to multiply everything by 8, and then add everything to the left-hand side, so we'd get 3x plus 8y plus 13 equal to 0. But for this question, either of these answers would be fine. But just be aware, sometimes they might ask you for the line in a certain specific form. Okay, let's look at another example involving tangents. This one's going to be quite long. This question says, a circle C has equation x take 5 all squared plus y plus 3 all squared equal to 10. The line L is a tangent to the circle and has gradient negative 2. Find two possible equations for L. And here is a diagram of what's going on here. So we have a center at 5, negative 3 from the equation, and the radius, remember, is the square root of this number, so it's the square root of 10. And the reason it says two possible equations for L is because the tangent either could be up here, so this would have a gradient of negative 2, or it could be down here. This line would also have a gradient of negative 2. So we're going to get two lines with two equations, and we need to find what those equations are. The first thing we'll note is that the equation for L will look like this, y equal to negative 2x plus c. We already know what the gradient is. The problem is finding c. So we're looking for two values for c. So how do we do this? Well, the first thing we want to do is to find the two intersection points where the tangents intersect with the circle. We want to find the coordinates of these points. So then the problem is, how do we find these intersection points? How do we find those coordinates? To do that, we need to find the equation of the diameter connecting those two tangents. So that's what we're going to start with, finding the equation of the diameter. Okay, so using the point gradient equation, we have the gradient because this diameter will be 90 degrees to these tangents, and we know the gradient of the tangents. They've told us that in the question. So we know the gradient of the diameter, and we have a point on that diameter, so we can find the equation, plugging those in, using the center as the point. So y1 will be negative 3, substitute it in there, and 5 is x1, so substitute that in, and the negative reciprocal of negative 2 is a half, so that is where that gradient comes from. Okay, simplifying this, also making a note that the gradient is the negative reciprocal of negative 2. We have y plus 3 equal to a half x take 5 on 2, and then subtract 3, and we get y equal to a half x take 11 on 2. We have the equation of the diameter now. Now we want to find where that line intersects with the circle. And we went through how to do this in part 1 of this series. We talked about how to find where straight lines intersect circles. The way we do this is we substitute that equation in to the equation of the circle. Okay, so here's the equation of the circle. X take 5 all squared plus y plus 3 all squared equals to 10. We substitute this half x take 11 on 2 into this equation for y. This will give us the x coordinates for where the diameter intersects the circle, these two red points. Okay, so let's substitute that in. We get x take 5 all squared plus a half x take 11 on 2 plus 3. We can see where that's come from. All squared equal to 10. Let's simplify. Negative 11 on 2 plus 3 is negative 5 on 2. Then let's expand these brackets out. We're going to get x squared subtract 10x plus 25 plus x squared on 4 subtract 5x on 2. When you expand these brackets out, you'll get 10x over 4, which I've simplified to 5x on 2. So I've taken a couple steps between these two equations. And then negative 5 on 2 squared is 25 on 4 equal to 10. Let's keep simplifying, and here, because I don't like working with fractions in equations, I'm going to multiply everything by 4. So I'm going to multiply everything by 4 to get rid of those fractions. I think it makes it simpler. So multiplying all of those terms by 4, x squared times 4 is 4x squared, negative 10x times 4 is negative 40x, 25 times 4 is 100, x squared on 4 times 4 is x squared, Negative 5x on 2 times 4, well, 2 would cancel with one of the 2's in 4, so we just get negative 10x. 25 on 4 times 4 is 25, 10 times 4 is 40. And now we can simplify this a lot more because we can combine all of these like terms. So 4x squared plus x squared is 5x squared. And also negative 40x take 10x is negative 50x. 100 subtract 40 is 60 plus 25 is 85. So we get this nice neat quadratic here. Can you see any common factors? Hopefully you notice there's a 5 in all of those terms. So divide by 5. We would get x squared take 10x plus 17 equal to 0. And now I'm going to clear the board and continue solving this quadratic. To solve this, you could either use the quadratic formula or completing the square. I would suggest when there is no coefficient of the x squared term to use completing the square. At least I find it a bit quicker than plugging everything into the formula. So using completing the square, we take half the coefficient of x, which is negative 5. That goes inside the brackets. X take 5 all squared, and then we need to subtract 5 squared. So subtract 25, then we have that plus 17 on the end. Negative 25 plus 17 is negative 8. Add that to the other side, so we have x take 5 all squared equal to 8. Take the square root of both sides. So we have x take 5 equal to plus or minus 2 root 2. So I've taken the square root and also simplified that surd in one step. So the square root of 8 is the same as 2 square root 2. And then add the 5 to the other side, and we have x equal to 5 plus or minus 2 root 2. So after all of that, I have the x coordinates for where this diameter intersects the circle and also where the tangents intersect the circle. I also need the y coordinates. So to find the y coordinates, I can plug this into the equation for the diameter, which looks like this. So that was y equal to x on 2 take 11 on 2. That was from our previous page of working out. I'm going to be a bit lazy here. I'm going to plug them both in at the same time. If you're not comfortable with this, I would suggest separating them out. So plug in 5 plus 2 root 2 first and get the y coordinate for that. And then plug in 5 subtract 2 root 2 and get the y coordinate for that. But we can do it both at the same time as well. So because these have the same denominator, I can just do 5 subtract 11. So I can just add and subtract the numerators. So 5 subtract 11 is negative 6. So we get y equal to negative 6 plus or minus 2 root 2 on 2. Both of these terms can be divided by 2. So negative 6 divided by 2 is negative 3. 2 root 2 divided by 2 is just root 2. So we get the y coordinates of negative 3 plus or minus root 2. Okay, so our coordinates then are 5 plus 2 root 2 and negative 3 plus root 2 and 5 take 2 root 2, negative 3 take root 2. Let's make a note of those on our diagram. So this point up here is clearly going to be in the positive x direction. So this is going to be 5 plus 2 root 2 over here and negative 3 plus root 2. This one's going to be further in the negative direction, so it'll be 5 take 2 root 2, negative 3 take root 2. And now that we have those two intersection points, we can find the equations for those two tangent lines. We already have the gradient that was given to us originally in the question, so we can find the equations for L using the point gradient equation, plug those in. I'll start with this point up here. We have y subtract negative 3 plus root 2, that's the y coordinate, equal to negative 2, that was the gradient, multiplied by x subtract 5 plus 2 root 2. Let's expand and simplify. So this is y plus 3 take root 2 equal to negative 2x. Now, I've taken a couple steps in one go here as well, so just be careful with those signs. This would be inside the brackets, x take 5, subtract 2 root 2, and then you expand out the negative 2, you get negative 2x plus 10 plus 4 root 2. And negative root 2 and 4 root 2 are like terms, so I can add that root 2 to the right hand side and subtract 3, and I get y equal to negative 2x plus 7 plus 5 root 2. So that's one possible equation. Let's find the other one by using the other point, plugging that into this equation. We would get this. So we have negative 3 negative root 2 as the y coordinate and 5 take 2 root 2 as the x coordinate, and simplifying we would have y plus 3 plus root 2 equal to negative 2x plus 10 take 4 root 2, which simplifies to y equals negative 2x plus 7 take 5 root 2. And finally, we have our answer. So the two possible equations for L are these, and we are done. As you can see, the solutions to these types of questions are quite long, and I want to go over the 4 main things we did there. So going back to the start, remember we found the equation of the diameter first, then we found where that line intersects the circle to find these points here, where the tangents intersect the circle. Next, we found the y coordinates of those points, and finally, we could use those 2 coordinates to find the equations for L. So generally, when you're answering these types of questions where you need to find possible equations for tangents, if you follow those 4 steps, you should be fine. Because those questions were fairly involved, I think I'm going to leave that there. And here are your homework questions for this video. Question 1 says the points R and S line a circle with center A, negative 2, as shown in the diagram. R equals 2, 3, and S equals 10, 1. M is the midpoint of RS. The line L passes through M and C. Part A says find an equation for L. Part B says find the value of A, and Part C says find the points of intersection A and B for the line L and the circle. So notice that last part is worth 6 marks. That's because there's a fair amount of work in order to solve that and find the points A and B. Question 2 says the circle C has equation x plus 5 squared plus y plus 3 squared equals 80. The line L is tangent to the circle and has gradient 2. Find 2 possible equations for L, giving your answers in the form y equals mx plus c. And I made a note, it can be useful to draw a sketch to get started if you're struggling to know where to start. I'll leave answers to those 2 homework problems in the description so you can check you did them correctly once you've given them a go. Hope you found this video useful. I didn't think I'd be spending this much time on circles, but there will be a part 3 to this series because there's still quite a bit to cover, so look out for that. Thanks for watching, and I'll see you in the next one. Bye for now.